Have you ever been out playing in the yard, maybe catching a ball, and said, wow, I just thought of something. I'm going to sit down and give this some serious thought. Well, Ellie frequently does that, and when she gives things serious thoughts, she's usually thinking about tennis balls. In this case, what Ellie's thinking about is what if there were two people, both with tennis balls, and one of them is about 1 dog unit high from the ground, and that person's going to drop a tennis ball so Ellie can catch it. The other person is about 3 dog units off the ground, and that person's going to drop a tennis ball, and Ellie, of course, is going to catch it. What she wants to know is, how do the two velocities compare? Are they going to be the same? Or is velocity 2 going to be perhaps 2 times larger than v1, going really fast? Or because the guy is 3 times higher, is velocity 2 going to be 3 times the velocity of v1, going really, really fast? Or would she be really lucky and velocity 2, for some strange reason, be 6 times faster than v1? Wow. Those are the sort of questions that Ellie thinks about when she's catching tennis balls. From such a very simple question, what is the relationship between the height released and the final speed of a ball being dropped, Newton got the universal law of gravitation, which got us to the moon. Really simple questions can make some really good physics. But in this case, we're going to take Ellie's really simple question and make it a little easier to test in the lab. What we're going to do is take a ramp, a nice long ramp, and we're going to release not a tennis ball, but a little marble. And we're going to say that this right here, this place where it reads 1 meter, is our reference point. And we're going to go 5 centimeters above that. So we're going to have a difference of 5 centimeters, which of course you're going to convert to meters. And then we're going to go up a little bit higher, and we're going to have a difference of 10 centimeters, which of course you're going to convert to meters. And then we're going to go up a little higher, 15 centimeters, 20, 25, 30, and you get the idea. You need to have at least 15 different evenly spaced release points as you're collecting your data. We want to have a lot of data. Maybe not as much as the Higgs boson had, but still a fairly good amount of data. At the bottom of the ramp, right after this 1 meter point, we're going to have a photogate timer. The way the photogate timer works is we've got this photogate part, and this photogate has a red infrared beam that comes flying out from one side and goes over to the other side where it's caught. At least that's normally what's happening, and when that happens, it sends a signal through the phone cord to the timer part, saying, everything's okay, don't do any timing. But when a marble comes through and breaks the beam, gets in the way of it, then it doesn't reach the other side. And then the signal to the timer is interrupted, and the timer starts timing. Then, as the marble gets away from it, the photogate again sends an infrared beam through, and once again it sends information to the timer. So while the marble is passing through the beam, the timer times that time interval. So we get a time interval telling us how long the marble stopped the beam. The time interval is the time the marble is in the photogate blocking the infrared beam. Using the equation v, velocity or speed, equals distance divided by time, where time is the time interval that the infrared beam is blocked, and d is the distance that is traveled by the marble during this time. But the distance traveled by the marble is just the marble's diameter, and that's 0.019 meters. So, for every release point, the velocity is equal to 0.019 meters divided by the time interval. The signal from the photo gate goes through the phone cord to the timer portion. Because we only have one phone cord hooked up, it should be going into the A port, and the A light should be lit. If it's not lit, you can turn it on by pressing the button. The B light should not be lit. When you first start using the timer, these numbers should all read zeros, and you can get them to 0 by pressing the reset button. Because we're looking at the interval that the marble is blocking the photo gate, the interval light should be on. And of course, you can turn it on by pressing this button, and it can step you through all these different ones until the interval one gets lit. We're recording it in seconds, so our units is going to be seconds. Hertz, we're not going to use this semester. We'll use it second semester. In this particular run that I did, we have 0.0080 seconds. That last digit is significant. So when you're writing down your data, you need to include all 4 numbers. They're all significant. These photo gates are truly awesome. When we're using the ramp, you want to be consistent about where you're releasing the marble. So if we were to draw a little dashed line here from the 75 mark, you might want to always have the marble so that the very front of it is right in line with the 75. And then when you go back up to the 70, you want again the very front of the marble to be in line with that 70. Same thing right here. In experiments, things like release points need to be held constant. And that consistency, or constants, is really, really critical. You're going to find that taking the data goes really fast. What we're going to have a little more difficulty, and what we want to concentrate on, is writing it up. Before you come into the lab, after you view this, you should write down your hypothesis or purpose. And this is really a purpose because we don't really have an educated guess. It's going to be something like determine the relationship between the release of the marble and the speed of the marble. You're going to want to put down your independent variable and your dependent variable. While this hypothesis and purpose is part of the scientific method, independent and dependent variables is something I add in there to make sure that you explicitly state them so you truly know what they are. Independent starts with an I. It's what I'm changing. What I'm changing here is the release point. Dependent starts with the D, just like the data I'm getting. My final data that I'm going to get, I have to calculate, but it's going to be the speed of the marble. So I want you to be explicit about what your independent and dependent variables are. Next, you're going to draw an equipment sketch. And we should have a labeled diagram indicating what the equipment setup is. In this case, we have a ramp, and then we have a physics stand holding it. I've got to label these things. The bottom of the ramp, we have a photo gate, and that photo gate is hooked to a timer. And of course, we can't forget the fact that we're going to have a marble. With the equipment sketch, it takes the place of listing out all the equipment, and it has the advantage of showing you how it's going to be set up. It works well for a lot of physics experiments. Not all, but for a lot of them. Next, I want you to write up a procedure. Okay? And you're going to have to come up with a procedure. The procedure is a series, and they're usually numbered as steps, of statements that gives a general idea of the procedure being followed. In this case, it would be logical to have about 5 or 6 steps. We don't want a lot of detail, but we want enough so anybody can follow it. So 1 might be set up equipment. 2 might be something like release marble at some specific point. 3 might be record the release point. Well, you should probably put that up here. Release the marble at some point and record. Down here, you're going to say record the time, and then next you might say repeat steps 2 through 3, going up by 5 centimeters every time. And step 5, you could say analyze data. The data section, you're going to have to put in your own table. I've already put one in, just to give you an example. It doesn't have to look exactly like this. I always like to have trial numbers just so I don't forget which one I'm doing. A trial number won't have any units. The release point, remember that's the difference between 1 meter and where you're releasing it. So you're going to have things like 5 centimeters, but of course you're going to convert it to meters. The time is just what the recorder records. This velocity column over here is something that you're going to have to calculate. And while you're really doing that in the analysis section, it is usually handy to have something like that up here in the data. So after you collect all of your times, you can go back and easily calculate the velocity. Next up, we have the analysis section. The analysis section indicates what was done to the data. In this case, you're going to be converting time to a velocity. It gives the equation used, and it gives a sample calculation. You're not going to show every calculation for every single piece of data. You're just going to show one of them, a sample. So what did we have? We said we were going to use the equation V equals D over T. We said D is always going to be equal to the diameter of the marble. We said T is the time interval, and that time interval is going to change for every trial. So you're going to have a time interval 1, you have a time interval 2, and so on. A sample calculation might look like this. After you get done doing your first sample calculation, you're going to have to make a decision about how many significant digits you have. I have 3 significant figures here and 4 here. I'm doing that multiplication, so the final answer should only have 3 significant digits. This one is showing 4 significant digits. So I'm going to need to round my final answer to get it into correct sig figs. In this case, it would round to 2.38 meters per second. After you fill in all of that data, the next thing you're going to have to do is put in a printout of a graph, which means you have to make a graph. So you're going to use the release point as your independent variable, and the release point, our independent variable, goes on the x-axis. And then you're going to use the velocity, our speed, as your dependent variable, and that's going to go on your y-axis. This is going to be in meters, and this should be in meters per second. And to make that graph, you're going to use graphical analysis. If you don't remember how to use graphical analysis, there's another short video that you can watch in the middle of this experiment to remind you how to do it. Thank you for your time.